Today we will be solving for the pH, concentration of H+, pOH, and concentration of OH of a weak acid using this example problem. What is the pH, pOH, H+, and OH- of a 0.25 moles per liter acetic acid solution using the given Ka constant of 1.50 times 10 to the negative fourth power? Now our first step is to write the reaction. Acetic acid C2H4O2 plus water H2O dissociates into a hydronium ion H3O plus an acetate C2H3O2. Our next step is to draw our ice chart, which stands for initial, change, and equilibrium. We will start to fill out our ice chart by placing 0.25 moles per liter as our initial acetic acid concentration. Because the reaction has not begun, both of the products, hydronium and acetate, will both have the initial concentration of 0. Next, we move on to change. Because the change of the concentration of acetic acid is unknown, we will be using the variable of x. Now that the reaction is in progress, the concentration of the reactants will be decreasing by x, as the concentrations of the products are increasing by x. Now we move on to the equilibrium row. The equilibrium concentration of acetic acid will be 0.25. It's safe to assume that it will remain unchanged from the initial, because the value of x will be too small to result in a noticeable change. Both products of the reaction will have an equilibrium concentration labeled as x. The concentrations of H2O are unnecessary, since H2O is a liquid and does not play a role in equilibrium. Now it's time to solve for x using the Ka equation. Ka equals the concentration of hydronium times the concentration of acetate over the concentration of acetic acid. Taking the information we know from the chart, our equation will be x times x over 0.25 equals 1.50 times 10 to the negative fourth power. To isolate the x variable, we will multiply both sides by 0.25. Now, x squared equals 1.50 times 10 to the negative fourth times 0.25. Now we will square root both sides so that x equals the square root of 1.5 times 10 to the negative fourth times 0.25. X will equal 0.00612, or 6.12 times 10 to the negative third power. By solving for x, we have found our hydronium ion concentration. Since the hydronium ion concentration is equal to the hydrogen ion concentration, our value for H+ will be 6.12 times 10 to the negative third power. This is a chart that shows you all the equations that are necessary to find pH, H+, pOH, and OH. To find the pH, we will be using the equation negative log of the concentration of H+ equals pH. The negative log of 6.12 times 10 to the negative third power equals 2.21. Since we have found our pH, we can use the equation 14 minus pH equals pOH. 14 minus 2.21 equals 11.79. Using the pOH value that we've just found, we will use the equation 10 to the negative pOH power equals the concentration of hydroxide. 10 to the negative 11.79th power is equal to 1.62 times 10 to the negative 12th. We have completed the problem and found the pH and friends of a 0.25 moles per liter acetic acid solution.